Good afternoon, everyone. Thank you for the opportunity today to share my vision, understanding, and experience in AI and what it means for medicine and healthcare. So here is a roadmap for where we are headed in this presentation. I will start with the state of AI, viewed from my eyeglasses, which you might want to borrow after my talk. So if you need one for yourself, you may need a prescription. So good luck with that. So let's take a quick look at the history of AI, the few milestones first. Then we will go over how AI is transforming everything in healthcare. At the end, I will talk about the future of AI in healthcare, and again through my eyeglasses, with a little bit hallucinations. So for the first time in human history, human brain is no longer a closed system. Intelligence is now scalable, shareable, and open source. AI is advancing at exponential speed, measured in models and days, not months or years. So let's do a quick system update for our brains and to get everybody on the same configuration. So AI is now eligible for the Mensa Club, which is for the top 2% IQ testers. AI received Nobel Prizes last year in both physics and chemistry. AI is no longer just advancing science. It is changing how science is conducted and what science even means. According to Demis Hassabis, the Google DeepMind CEO, AI is going to make disease history, maybe in 10 years, according to him. And Bill Gates said AI could replace many doctors and teachers, again, maybe in 10 years. AI will be as smart as the smartest artist in a few years, 3 to 5, according to Eric Schmidt, the former CEO of Google. Sam Altman, the OpenAI CEO, stated that AI will fundamentally change what we teach and learn at schools. And UAE is the first country to use AI to write laws. Mark Zuckerberg claims that most of your friends will be AI very soon. And Moderna talked about why it merged IT and HR into one department, because AI can do a lot of things that humans do. And Jason Huang, the CEO of NVIDIA, said new jobs will be created, some jobs will be lost, and every job will be transformed. So the list goes on and on. This is not hype. Today is the James Watt moment for the human mind. Engines liberated the body, and they smashed the cost of physical labor. To go to New York City from Houston, it takes 3 months if you walk, 3 weeks biking, 3 days driving, and only 3 hours if you fly. With engines, time dropped by 99% and cost by 97%. So now AI is doing to the mind what engines did to the body. Imagine an AI agent educated at Princeton, Harvard, MIT, and of course UT Health Houston combined, who has read every book in human civilization, speaks every language in the world, human or machine, who never sleeps and asks for nothing in return. So I did an experiment to find all the AI in healthcare courses across 156 medical institutions in US. It takes 100 hours by hand, 40 hours if you use Google search without AI, and only 2 hours with AI. So I did this myself. I can tell you the data are pretty much there close. So AI is shattering the cost of cognitive labor. Basically, the saving is 98%. And we are very proud that Texas is leading AI education in healthcare in the nation, with a total of 6 AI courses dedicated to healthcare, including 5 here at UT Health Houston McWilliams School of Biomedical Informatics. So let's take a very quick look at the history of AI. So AI, there are many definitions. One of them is that AI is the technology that allows computers to perform tasks that usually require human intelligence. AI is not just ChatGPT or Gen AI in general. Over the past 70 years, many algorithms and models have been developed, and many of them are still in use today in various forms. So AI's journey has had ups and downs, but today there's no turning back. It all started in 1956 at a small conference at Dartmouth, where the term artificial intelligence was first used. Jeff Hinton, a Nobel Prize winner last year in physics, was at the center of AI's 2 defining breakthroughs. In 1986, he co-authored the backpropagation algorithm with David Rumelhart and Ron Williams, laying the theoretical foundation for deep learning. And in 2012, he showed that deep learning could scale to real-world industrial applications. Then it came to the ChatGPT in 2022. So the rest is history. So here's what happened in 2012. At the ImageNet competition in 2012, the AlexNet by Hinton's team, although it did not beat humans yet, it beat every other model by a mile with only a fraction of computing. And that changed the landscape of AI forever. This chart shows the relative frequencies of AI data science and medical AI mentions in the entire Google universe. It's clear that everything took off in 2012. Let me play audio here.
This slide highlights the 3 key economic revolutions that have shaped human history and population growth. First, the agricultural revolution, around 10,000 BC, introduced farming and animal domestication, which allowed humans to settle in communities and stabilize food supplies. This was the foundation for population growth and more complex societies. Next, the Industrial Revolution, in the 18th century, used machines to replace manual labor, enabling mass production and driving urbanization. This was a physical transformation that increased productivity and accelerated global population growth. Now, we are in the cognitive revolution, driven by AI. This revolution is automating cognitive tasks like decision-making and analysis, transforming industries such as healthcare and finance. AI is changing how we work and will likely lead to the next wave of societal transformation.
So this chart was created by me by hand. Literally, the curve is not even straight, okay, by hand. What I did is I took a picture of this, sent to ChatGPT, asked ChatGPT to prepare a less than 1 minute speech for one single slide. So every word you heard is from ChatGPT. I did not change a single word, okay? So good performance interpretation, better than me, better than I could describe. And the speech is by my avatar, which I created by using the personal voice on iPhone. So I pasted the text generated by ChatGPT to the personal voice. What I heard is the speech generated by the AI. And this was done 2 years ago. Today's models are much better. So as you can see, AI is pretty amazing. There are many research reports on the future of AI in healthcare market. Here's one of them. So they all pointed to 20x, 30x or more growth over the next decade. So now let's take a look at what AI is actually doing in the trenches. So first, AI in education. This chart highlights just how far today's AI models have advanced in academic and professional benchmarks. The AIME, the American Invitational Mathematics Exam, admits only the top 2.5% of AMC 10 and 5% of AMC 12 high school students. Yet today's AI model scored more than twice as high from a human. And the latest models from Google and OpenAI, they even won the gold medal at the International Mathematics Olympia, which is the world's most challenging high school math competition. So beyond math, AI models excel on the GPQA, which is called Google Proof Question and Answers, which is a PhD level benchmark in physics, chemistry, and biology, and on MMLU, which spans 57 academic and professional subjects, much like a super SAT, and on the software engineering benchmark, SWE bench, which model can fix real-world software problems, bugs. So together, these results show that AI is not competing and even winning at the very frontier of human experience. So now let's get back to healthcare. This chart shows AI performance to human averages and passing grades on major health licensure exams. For medical and nursing exams, the best AI system consistently outperforms human averages and easily clear the passing grades. For example, AI models not only pass step 1, 2, and 3 medical license exams, they perform better than human average. The one exception is the dental exam, where human performance remains slightly higher, although AI still passes. The gap is likely to close as models continue to improve with domain-specific training. The key takeaway is that AI already demonstrates exam-level mastery across nearly all health professions, and this raises a critical question. What does this mean for the future of healthcare education curriculum? AI now supports learning at every level. In K-12, it acts as a personalized tutor, lesson planning aid, and others. In college, it enables auto-grading, content generation, coding support, problem solving. In graduate and professional training, it powers exam prep, simulations, and research drafting. The key point is AI is rapidly adapting to the unique needs of each education stage, from basic tutoring to advanced professional support. AI is reshaping both what we teach and how we teach it. So in K-8, the focus shifts to AI literacy, bias awareness, and social-emotional learning, while rote memorization is reduced. In high school, data science, media verification, and AI ethics take center stage, replacing timed essays with AI-supported portfolios. At undergraduate level, domain-specific prompting and interdisciplinary projects replace cookbook labs. And in graduate professional training, the emphasis is on human-AI collaboration with scenario-based assessment and other different ways to use it. So the message is that AI does not really replace education, it transforms it. So now let's go over AI in patient care. AI systems are progressing quickly in diagnosis. So this is the AI system developed by Microsoft for diagnosis. It was published a few months ago. And the chart shows its performance compared with the human physicians and other AI models. The diagnosis questions are from the New England Journal of Medicine, which are very difficult cases. So physicians average about 20% correct. But AI reached nearly 80 to 90% accuracy. That's almost 4 times more accurate. And it also achieved this with fewer and less costly diagnostic orders. The key takeaway, AI delivers both higher accuracy and greater cost efficiency outperforming position for this specific task. And AI products are quickly shaping patient care. We see AI in diagnostic imaging, flagging urgent findings and serving as a second reader in cancer screening. Predictive and risk models provide early warnings and support proactive rounding. Virtual triage chatbots enable patient self-screening and routing to care. On the workflow side, ambient AI scribes auto-generate visit notes and orders, while acute care coordination tools push findings and route data across teams. In treatment, therapeutic and autonomous devices guide surgical or biopsy robotics. And the next but not the last, digital twins allow patient-specific virtual simulations for precision decision support. So together, these categories show how AI is now embedded across the full spectrum of diagnosis, workflow, and treatment. AI is already delivering measurable clinical impact. For instance, with AI speeds stroke alerts by 40 minutes, ambient tools cut documentation time by 30% and reduce burnout by 15%. Google's AI mammography improves cancer detection by 17%, and Armada's digital coach lowers A1C in diabetes. In short, AI is making care faster, easing clinician workload, and improving patient outcomes. AI is redefining how research is done in the biomedical field. As I mentioned earlier, AI won the Nobel Prize in physics last year. However, Hopfield and Hinton's breakthroughs were really in AI, not in physics at all. But the Nobel Committee chose to honor them in physics because, frankly, in my opinion, they did not want to miss the AI party. This shows how profoundly AI is reshaping all fields, even how we think about the boundaries of science. So AI is not just ChatGPT or large language models. Last year, the Nobel Prize in chemistry was given to computational scientists and engineers, including 2 from Google DeepMind, for breakthrough AI models such as AlphaFold. What once required one entire PhD dissertation to determine the 3D structure of a single protein, AlphaFold accomplished at scale, solving over 200 million protein structures in just 1 year. To match this achievement would take, I did a calculation, 200 million dissertations, or more than 650 years of global PhD production in all academic fields, not just biology. So this is condensed by AlphaFold into a single year. So it's really amazing. Here is another recent example of AI in biomedical discovery. AlphaGenome, again by Google DeepMind, represents a major breakthrough in genomic prediction. Unlike prior models that handled around 200K base pairs, AlphaGenome works at a scale of 1 million. It predicts over 6,000 genomic features across tissues and species, and uniquely integrates gene expression, splicing, chromatin states, 3D structures in a single framework. On benchmark test, it outperformed leading models on 24 out of 26 tasks. Most importantly, it's accurate, efficient, and fast, making it ideal for both research and clinical diagnosis. So AI is reshaping biomedical discovery. AI predicts protein structures, as we saw, and genomic features, and even designs new proteins and RNAs. It accelerates drug discovery through generative chemistry and robotic lab, and supports researchers by mining literature and drafting hypotheses. Finally, it streamlines clinical trials with smarter site selection and monitoring. AI has profound implications for the research enterprise. AI can now draft hypotheses, scale experimental throughput, and improve reproducibility with robotics. It's also shifting the workforce toward computational bench scientists and raising new questions in ethics and governance. The key challenge is not just adopting these tools, but addressing the strategic questions they raise, from authorship to training needs to auditing model drift and aligning with national projects at NIH and other agencies. Most of the implemented healthcare AI products are actually in operation, not in the direct care of patients. So AI is redefining healthcare operations. Beyond clinical care, AI automates revenue cycle tasks, drafts documentation, and predicts patient flow. It also optimizes scheduling, supports call centers, manages supply chains, and even maintains facilities. In short, AI is streamlining the entire operational backbone of health systems. And AI is driving measurable operational impact. Here are a list of some published studies. At Kaiser, Nuance DX Copilot saved 16,000 documentation hours and cut after-hour EHR time for the physician by 30%. City Cora reduced patient billing costs by 30% and cost by 22%. Cuventus boosted OR utilization by 7%, and GE's command center cut ED boarding time by 20 minutes. And Optum's Delio AI lowered first pass denials and accounted for reduced appeal drafting time from 45 minutes to just under 5. So these metrics demonstrate AI's ability to save time, reduce cost, and improve efficiency across healthcare operations. So AI is bringing enormous impact in healthcare, but also real risks if left unchecked. Safety must come first, protecting patients and communities. Thoughtful regulations like the ones in aviation ensure innovation without harm. So our responsibility is to guide AI with guardrails so it serves humanity, not the other way around. So don't be amazed by this generated by AI, but I did fact check for everything. So I agreed with everything that was generated. It's a good summary. And here are some of the ethical and practical challenges of AI in healthcare. Predictive models, large language model, clinical decision support systems, each raise issues around bias, privacy, transparency, and accountability. On top of that, poor usability can magnify risks and reduce trust. The key message is clear. Advancing AI in medicine isn't just about performance. It's about ensuring fairness, safety, and responsible integration into patient care. AI regulation is rapidly evolving. In the US, we see federal action through the 2023 executive order. Then in 2025, the new Removing Barriers to American Leadership in Artificial Intelligence executive order revokes certain prior constraints, and the focus is on AI innovation. States are moving at a different speeds with both proposed and enacted laws. Globally, the EU AI Act is setting one of the strictest frameworks. So the key takeaway is clear. AI governance is no longer optional. It's becoming a patchwork of mandates that institutions must navigate carefully, especially the mandates come all the time and change all the time. So Liam knows that really well. Okay, so now let's get into a bit about the future of AI in healthcare. This article that we recently published emphasizes that AI is transforming healthcare education into a distributed human AI system. So over the past several thousand years at a minimum, the human biological brain really has not changed much. But the AI's knowledge and reasoning power are expanding exponentially. This means education must now focus on preparing students to work with AI, to solve complex problems together, and to adapt curriculum and policies to this AI-augmented reality. The humans and AI function as a unified system. By removing silos, AI helps create shared knowledge that allows us to tackle problems more holistically. And in this context, memorization alone is no longer sufficient. So future healthcare education must emphasize creativity, ethical reasoning, problem solving, and above all, collaboration with AI. Here is a comparison between human and human plus AI for a clinical diagnosis case, a patient presenting with chest pain. So the red boxes are performed by human, and the green boxes are by AI. So both begin with history, risk factor, physical exam, and both generate a similar differential diagnosis and all the appropriate tests. Where AI stands out is in speed and pattern recognition. Humans, however, bring contextual judgment, human-only tasks, empathy, and the ability to handle uncertainty. The real shift is not just about human versus AI, but how the very nature of tasks is changing. From data entry to data verification, from memory knowledge recall to recognition, and from generating hypotheses to evaluating hypotheses. This redefines the role of healthcare professionals in an AI-augmented future. This recent article asked if we are ready for AI-augmented generalist. AI is reshaping medicine by unifying the knowledge of specialists into a single system and serving as both a knowledge base and an active cognitive collaborator. Physicians empowered by AI can function as generalists who bridge knowledge gaps, reduce fragmentation, and return to hopefully more integrated medicine. But to realize this potential, we must rethink how we train and educate the healthcare workforce. Okay, it's one of my favorite books by Thomas Friedman. He basically argued very, very nicely the internet flattened the world of information. So today, AI is flattening the world of intelligence, which is now shareable, scalable, and free and open source. So we stand at a historic inflection point in healthcare and science. AI is no longer reserved for the most established. AI power is abundant, low cost, and accessible to all. In this environment, speed is the differentiator. Advantage will belong not to the richest institutions, but to the both institutions that adopt, adapt, and scale decisively. The question is not if AI will transform the field, but who will lead it. And this is the UT Health Houston's moment. Let's see why and how UT Health Houston can take the lead. So UT Health Houston is the first academic medical center in the US that signed a HIPAA-compliant institution-wide contract with OpenAI a year ago. And we have 7 wonderful schools, very comprehensive in almost all the field of healthcare and medicine. And UT Health Houston is the home of the largest informatics program in the nation, and it's here, McWilliams School of Biomedical Informatics. And we are still the only freestanding school of its kind in the nation. We have over 800 people, I just got updated today. We have, instead of 819, we have 854, so we're still growing. We have a dedicated department in AI, and we offer education programs across the entire spectrum of graduate education. And we also develop products of AI for real operations. So let's take a quick look here. Our school has 8 core courses on AI and 18 courses in expanded areas of data science and additional 28 courses in the broad field of informatics. And we are an AI pioneer. So AI using education is permitted unless it is prohibited. It's totally opposite to what most institutions do. We focus on discoveries made and problems solved, whether the discoveries or solutions are generated with collaboration with AI. So at UT Health Houston, we have built one of the most active and largest scale AI research portfolio in health sciences. Our teams are advancing AI across nearly every major sub-area: imaging and diagnostics, predictive analytics, clinical decision support, drug discovery, and genomics. We're also leading in monitoring and wearables, healthcare automation, educational and assistive AI, and emerging applications. So the breadth of our work demonstrated that we are not just participating in the AI revolution, we are helping define it for medicine and healthcare. Okay, UT Health Houston has been very successful in getting medical AI grants from NIH. For example, 2 years ago, during a 2-month period, we received 15 NIH grants with a total of $31 million across the entire grant period through collaboration between medical school and McGuinness School of Biomedical Informatics. And during 2021-2024, UT Health Houston received 56 million AI-related grants from 14 institutes of NIH. As you can see that the McGuinness School is the leading recipient for most of AI grants. And you can see different institutes over there, different areas of AI in medicine. So most recently, last week, UT Health Houston received 27 million NIH grant to establish the Data Coordinating Center for Alzheimer's disease and related dementia, led by Jiajie Zhang, whose primary is in neurology in the medical school with joint appointment with the School of Public Health and McGuinness School of Biomedical Informatics, and our faculty member Hongfang Liu and Lichong Cui. They are the co-PIs for this large grant across 10 institutions. So this center will make real-world data available and ready for advanced AI research. We are also good at publications. And we have a lot of publications over the past 4 years, over 600. Again, you can see that our school is a major contributor to most of our publications over there in medical AI field. And in patient care, our clinical IT team is a forward-thinking, AI-driven national leader, earning EPIC Gold Stars Level 10 for 4 years in a row. And they are deeply enthusiastic about bringing AI solutions to our clinical practice. UT Health Houston has been highly active in advancing AI solutions to strengthen clinical operations. The Center for Digital Health Innovation, led by Dr. Martin Sitardi and Dr. Fatui, and Jiajie Zhang in the School of Biomedical Informatics, they have developed dozens of AI solutions, mostly for operations and for the clinical practice. So we are very active in this area. Some applications have hundreds of users, and it's affecting our operation and saving money, reduce cost, reduce burnout. So to build on our strength and seize the emerging opportunities, UT Health Houston launched an institution-wide AI task force in May this year. The task force is charged with guiding our path as AI-native institution, developing a clear vision, assessing current capabilities, setting strategic priorities, and recommending high-impact initiatives, all grounded in strong governance and cross-institutional collaboration. Our AI task force brings together leaders from across all 7 schools of UT Health Houston and our clinic partners. This is truly a whole institution effort with more than 80 faculty and staff volunteering to shape this important initiative. The task force is chaired by myself with dedicated support from our management team and legal advisor, who is right here, Liam. Make sure they'll do the right thing. There are 7 subcommittees on research, education, patient care, technology and implementation, data platform, governance and policy, and partnerships. So together, this broad coalition is laying the foundation for UT Health Houston to become one of the nation's first AI-native health science universities. So as the chair of the task force, I want to note that we have not yet defined the UT Health Houston's AI vision. This will be a collaborative process over the next few weeks with the entire team. But what I share here is my first draft, personal perspective, meant as a starting point of discussion. So the vision in my mind is that UT Health Houston will shape the future of health as one of the first AI-native health science universities, where AI is architected into the fabric of data, workflow, culture, governance, and decisions, continuously learning to power smarter care, more efficient operation, faster discovery, and a redefined education and a workforce training. It is not just adding more ChatGPTs, it's a more systematic approach from the very foundation. Okay, so the last slide. So people always ask me, what can AI never be capable of doing? I thought about this all the time, and I do have one because I tried to use AI to do it. I failed. AI could not deliver what I wanted. So this is a speech I gave 1 year ago. It is not at a conference or a research seminar like today. It is at my daughter's wedding. Okay, so if you are curious about what I said, scan the code, you can listen to the speech. It's online over there. No AI model could have written that speech, not because it lacks intelligence, but because it does not have a beating heart and a whole life behind it. Simply doesn't have it. So again, you can check it out and tell me if you can get it. So here is my challenge to you all. If you can build an AI agent or system that can write that speech and make me cry, literally I cried during my speech, just let you know. If you can do that, I will resign from my job as a human. Thank you so much.